Okay. All right. So we're doing we write polar coordinates, right? In different I'm recording, yeah. Okay, so let's go back and look at let's see where we started off at. Yeah, and then we jump into today's lesson, okay? Let's see. Uh, that's not it. Here we go. What's next? Oh,
Break it again.
yeah. Okay, this thing's not coming off. I don't know why it does that.
Are you in the stop share?
I'm gonna pause. Okay, please. What was D? Do we do D? No, let's do that now. So remember now, identify two other points, right? I can write this point as where the angle is between -2 pi and 2 pi. Okay, and so remember, I said this yesterday. Uh, so these are different format we can use. Given a point r comma theta, right? I can write this at, if I keep the r the same, r, then I add 2 pi to the angle, or I can minus 2 pi for the angle. Good? Or if I put the r down, if I make the r negative, then I just gonna add pi to the angle or minus pi from the angle. Are we good so far? You guys remember that? No? Yeah, we did this like several times, okay? Now watch this now. If you add 2 pi to the angle, right? And this is good and it fits over here, then this is not gonna work. So you gotta go down to the other one, put the R value. Make sense? So if one of these two work, to find another point, you gotta form it, you gotta go to the other two of these two. Make sense? No? All right. So let's try D for a second. Let's try D. I'm gonna give it a couple minutes to do D and then we move on. All right. Let me take a 10 minutes real quick. Yeah, you can, once you start, you can either add or minus 2 pi, right? You got just pick one. But if it works though, right? You have to go to the other two sets. And when the class ends, I'm gonna have you guys help me clear all the calculators. Yeah.
Yeah, it's easier if we all do it than one at a time.
I'll show you the oh, I think okay. Did I still have it here? No. So the last one is gonna be clear. It's gonna be home screen. Then it's 2 menu C. Then okay. All right. Okay. Are we good so far? Who's still struggling this? Who's still struggling? Okay, which part are you struggling? Huh? Yeah, go ahead.
Step 1 to the last step.
Okay, step 1, okay. Okay, so look at D now. Okay, we're gonna use one of these right here. Okay, so R is 5, the angle is what? 2 pi 4? Do you want to add 2 pi or minus 2 pi? You pick it. Which one do you want to go with? Okay, let's add 2 pi. All right, so it's gonna be 5. I'm gonna add 3 pi over 4 plus 2 pi. All right, Now, if I want to add these two now, they must have the same denominator. Agree? So if this is 1, this becomes what now? 4, and this becomes 8 plus 3 gives me what? 11. So we have 11 pi over 4. Now 11 pi over 4. Okay. When if I divide 11 by 4, is that going to be greater than 2? No, no, don't say. I mean, if I divide 11 by 4, is that going to be greater than 2? No?
Yeah.
Yes.
Exactly. So therefore, it's going to be on the outside of here. It's not going to be inside.
So we can't.
So plus 5 is not going to work.
Okay.
If plus 5 didn't work, then that's what's going to work. So minus 2 pi is going to work. Everybody see that, right? So therefore, let's minus 2 pi now. So 3 minus 8 is -5. So that gives me now -5 pi over 4. Right? -5 over 4 now. What does that give me? So is that going to be inside? Is that going to be over here or inside here? Inside. So that's the word. That's my angle right here, right? So this point now, one point is going to be 5 comma -5 pi over 4. Good? So therefore now, my first point comes from this group right here. So therefore I got to go up here now and find the other one. So we're going to flip R. So R is -5. -5 now. And we're going to add, the angle is 3 pi over 4. Do I want to add pi or minus pi? Which one do I want to do? Add pi? Just add pi. If I add pi now, this becomes what here? Huh? Yeah, remember, we need 2 points. The answer, find 2 other pairs. We found 1 pair, agree? So I'm going to add pi now. So this becomes what here? 4. This becomes what? What is 3 plus 4? 7, right? 7 pi over 4. Exactly. So that's going to give me 1 point strike. So it's going to be inside or outside? So is that going to work? Yes. So the other one's going to be -5 comma 7 pi. Yeah. Hey, what's up? Okay. Got it. All right, guys. So you got to pick up. Once you get the point, you got to decide which one do you want to do. Do you want to add 2 pi or minus? You pick that one. All right. And once that works, go to the other pair and add pi up to the R value. You good? Just like practice. I can't spend too much time on it.
Yeah, get on either side of it. Right?
Yeah.
Are we good? All right. Yes. Let's move on. All right, let's go. The next thing on the review is we did that.
Pedals?
No, not pedals. It's remember how to find the distance between 2 photo points? Yes, remember that distance? Yep. The distance is the long formula. D is equal to the square root of R1 squared plus R2 squared minus 2R1 times R2. Remember that?
You still gotta go.
Huh? Oh, cosine up there. I heard somebody snore while they're sleeping. Cosine of it. Okay, remember that, guys? Oh, you just plug it in
That one's easy.
Yeah. Exactly. All right. I'm not gonna spend time on this right here. I'm good.
Yeah. Good on that.
Your R squared, you start with the first, one be R1, and then you 0, 1, and then R2.
There you go, young scholar. You got it. You got it.
Wait, you're gonna get this straight up.
Ooh, you know something?
Look at the back.
Are we good? No stars. Are we good? Yes or no?
Good.
In the army, we go check the hole. Check.
Cool.
All right, here.
Get ready to jump out there, buddy.
All right.
Jump be good.
Hey, can I move on? Okay, one thing you must be aware of though, if you're using radians, what's the technical in? If you're using radians, you must be in.
Degree?
No.
Radians.
If you're in degrees,
Oh,
then-
yeah, yeah.
okay, yeah. Okay, are we good? All right. Can I move on from here?
Yeah.
Okay. All right. This is the fun part now. Remember how we write equations for polar graphs? Okay. Can anyone tell me what is the equation of a straight line in polar? I said polar. That's rectangular. What is a formula? Come on, guys. Oh, someone, Billy, hold on. There you go. What is it? Theta is equal to the angle, right? So if this is a straight line, yes, Rose, do you remember it now? All right. So remember, if it's a straight line, we use theta is equal to, and whatever the angle is, whatever angle line is going through, we use that angle. Are we agreed? I'm scrolling. You're on it today. I'm talking. There you go. Snap it. All right, good. So here, in this one here, what's my equation gonna be? What is the first one? What's my equation gonna be? Power 3. Oh, power 3. Are we good? Good.
Because you always go for the positive one first, right?
Either one is fine. Either one is fine. You can use power 3 or you can use the 4 power 3. Is it 4?
That's 4 5.
4 power 3. Are you checking what arm you're now? What we're doing right here? Checking arm. You're stretching arm. Are we good? All right. What about this one here? Last one. Come on. Okay, this is the 5 power. Okay, all right, got it.
Maybe it's 5 power.
You just put the number.
Which one? Yeah, exactly. That's all it is.
It doesn't matter.
No, I would not give you both angles. If it's a multiple choice, I would not give you both as answers because they're both correct. I'm gonna give you one of them. Huh? I mean, yeah, no, good point. No, he's okay. Yeah, he's showing me something. That okay. If you're talking in my class and you talk to another student about class, that's fine. Talk, that's good. If you talk about something else, that makes me mad. But that's not you could talk. It's kind of distracting to a work. I can live with that. Make sense?
All right.
It's all right. You know, we got about something else. That makes me mad. Good? All right. Now, question is this. All right. If I in the negative angle, this is negative pi over negative pi. I can't say it clearly. Negative pi over 6. Okay, got it. And this is 5 pi over 6. I'm not going to give you these two, right? Because they're both correct. Everybody see that? So I'm not going to give you 5 over 6 and negative pi over 6. They're both correct. Is we good? Make sense? Okay. All right. Woo! Circles. Okay, the first one, when this circle is at the center, how do we write the equation for that? So what is this one here? R is equal to what? Is it 2? 1.5. Okay. I know I can't see well, but and this one is R is equal to
4.
outstanding. I'm sorry. Good. You're making me feel good today. We look behind today. All right. Now, circle. Now, when this circle is not at the center, it's off center now. There's a
Look at that, look at that.
Wait, this.
hold on, young scholar. I mean, you're on it today. You're on it today. What I'm talking about. Yeah. There you go. I mean, she is cooking today. Woo! All right. All right. You're welcome. You're welcome. Emmanuel. See, I need you to be like that. No, Emmanuel. All right. There you go. All right. Yes. If it is vertical. If it's vertical, right, it is sine. So this is R is equal to A sine theta, right? And if it's horizontal, it is R equals A cosine theta, right? Got it. Good. Now remember now, the A value is the diameter of a circle, or the distance from the origin. Good. So here, this is origin. So this is 1, 2. So here my A is 2. Good. All right. So let's do this one here. What's the equation for that one?
R equals 5.
R is equal. Is it? Oh, there you go. Right. It is 1, 2, 3, 4, 5. It's on the polar axis, so it's cosine. Right, and the distance is 5. Outstanding. Can I move on from here? Good.
So on photographs, they're always cosine.
They're on the polar axis. What? On the power 2 axis, if it's vertical, that is sine.
Right.
That is sine. If it's on the polar axis.
Yeah.
All right. How we doing? All right. Okay, let's do this real quick. All right, I think you guys are good on that one. Hey, let's go to today's lesson, which is rose curve. Okay. Yeah, what is that? It's crazy, right? Now you've seen these shapes many times in real life, petals, right? They're called polar grass, right? They're polar grass, but we call them rose curves. Sometimes you see on textbook these beautiful shapes. Their graph is polar. Imagine trying to graph this with X and Y. You know, that's crazy. All right. You go ready? All right, good. So here are the equations for rose curves, right? The equation format is this. R is equal to A sine and theta. That's one way. R is equal to A cosine, cosine and theta. Good? Two formulas.
In theta.
And theta. I think my penmanship is not the best. Good? Okay. All right. The A is what is the distance from the center, right? So here, that is your distance A. That's the A. How far is the petal from the center? Good? So it's called petal length. That's A. Good so far? Now N. If N is an odd number, right? If N is an odd number, then that's how many petals you're going to have. Right? You have N petals. Are we good? I'm going to show you. I'm going to give an example of what I'm talking about. Good? XCMR petals. I'm going to show you what it is. If N is even, then you have 2 N petals. Ms. Simpson, give me an example. Here we go. Look at this one right here. Okay. The formula is, the equation is R is equal to A sine 2 theta. All right, everybody see that? But how many petals do you have?
4.
Right, because n is it's an even number. Everybody see that? So you get twice the more petals. Good, Rose?
Is that because it goes down below and it just
No,
reflects?
no, it's just the way they it's a good question. I'm trying to get a good answer. It's because of it's 2 times the angle. It makes it different when n is on. That's a good question. Kind of caught me off guard. Yeah. I gotta give a good answer. All right. Now,
Is it always it's like 4, 8,
yes. If you have an even pedal, divide it by 2, and that gives you the n value. Good. All right. And look at this one here. R is equal to 2 sine 4 theta. N is, what is n? How many pedals do we have? There you go. Everybody see that now? Let's look at an odd number now. Let's look at here. R is equal to A3 cosine 3 theta. What is my n value? 3. What how many pedals do I have? 3. Here. What's my n value? How many pedals do I have? 3. See that now? So when n is an even number, you have twice the pedals. Are we good? All right, outstanding. Good. Wait, so how do we graph these? Young scholar, and you stay with me on this. Are we good?
Yep.
Good. All right, here we go. Now, if you notice now, watch this now. When it is sine, right? Sine, the pedal, like for a second. When it's cosine, the first pedal starts on the polar axis. Every time it's cosine, regardless if it is odd or even. If it's cosine, the first pedal starts on the polar axis. If the angle is 0 right here. That is for cosine.
Is that every time?
If it's cosine. If it is sine now, the first pedal starts above the polar axis. Right? It's above. Right? The issue now is this. What is the angle here? Where does it start above the polar axis? What is that angle right here? Okay? Cosine, don't worry about it. It's always 0. Good? All right. How do we find this angle when it's sine? Here we go. Here we go. Let's do an example real quick. Let's use this one is not on your packet, right? I need to do this real quick. Show these things. Okay, let's use R is equal to 3 sine 3 theta. Good? Okay, what's my A value? 3. Okay, how many plus am I going to have? 3. Okay, good. Now, how do I know where that first pedal is going to start at?
It's going to start on the 0.
That's a cosine.
the sign.
Okay, I got you.
Remember, cosine starts on the
It's going to start up.
polar. Exactly. It's sine is going to start a little bit up. We want to know where it's going to start at. Well, let's see. This is how you do it now. First pedal. Okay. Divide 90 degrees by 3 by the end value. Right? Which gives you what? 30 degrees. Just take 90. Good question. Where does it come from? Just if I explain that to you, it's going to take.
And the second one's 180, right?
Okay. Oh, okay. Watch this now. Watch this now. Okay. So where's 30 degrees going to be at now? 30 degrees going to be, this is 45 right here. So 30 is good. All right. That's my first pedal now. I have 2 more to go. Where are they going to be at? Around here. Yeah, I'm going to show you now.
It's going to be at 180.
Let's see if it's 180. You could be right, young scholar. Let's see. Let's see. All right. Let's see if you're correct, young scholar. Okay. Now, I want to look. I'm going to have 3 pedals. Okay. The issue is now, what is the distance? What is the angle between all 3? Okay. How do we find an angle between all 3? What's this now? Take 360 and divide it by how many pedals do we have? 3. That gives me what?
One at the top.
Yes.
At the top of it.
Right, right here? Yeah, that's the equation right there.
So assume you have 6 pedals.
No, it is on. When it's good. All right, 120. That tells me now each pedal is gonna be 120 degrees apart from each other. That's what it means.
And that's after the 30 degrees.
That's after now. So therefore, now, if the first one starts here, right? Therefore, the second one is gonna be what now? It could be 30 degrees plus 120. Everybody see that? Will be 150, which is where's 150? This is 180. So where's 150 gonna be now? Kind of guesstimate. Yeah,
30 degrees.
somewhere around here, right? 150. Good. Okay, that's my second one now. My third one now is gonna be where? I get 240. If this is 150, then I have to add 120, right? So the third one's gonna be 150 plus 120. Everybody see that?
Yeah.
Remember, they're 120 degrees apart from each other. So if it's 150, then 120 going this way is gonna be where? 270. So the other one is right here.
So anytime we try to solve an angle, we just do 360 divided by the number of pedals.
Exactly. If you want to find what's how far they're from each other. Yeah. Okay. So now it looks like this now. All right. Ali, you gotta stay with me, brother. All right. So here we go. If you can't do that way, right? Because sometimes I'll miss one of them. Right, guys, if you can't do that way, just do this. Let's do this. See that? If you can do that. Good. Are we good? Let's try one more. Okay. Cosine's pretty easy because we know where cosine starts at, right? Sine to the one I give us problem. Okay, let's try let's erase this for a second. One more. You do? Let's try R is equal to 2 sine 5 theta. 5 pedals. Okay, good. My starting point now. Where's the first one going to be at? Let me draw. Where's the first one going to be at? 9 divided by what? All right, somebody. Damn. So the first one is going to be 90 divided by 5. All right? Okay.
This is the same thing for each.
Quick question to you. What if this was a 4 now? How many pedals am I going to have? But with the first one now, it's going to start where? How do I find what is the first one going to start at? Not 8, it's always by n. Always by n, right? All right, good. But then if you want to find out how many degrees are between all the pedals, you divide by 8. Good, good. All right, good job. Good.
Wait, so the first one, so you said it's going to be 90 divided by 4, 90 divided by 4, and then 360 divided by
8. Good, good. All right. All right, good. You guys, man, my 6th period, man, they had it rough. I mean, it's like we had a brick wall and I couldn't get him over the brick wall, you know? All right, here, ready? So what is 90 divided by 5? 18. So 18 degrees now is going to be, let's see, 30. 30 is right. 8 is probably somewhere down here. I'm not going to just something getting close, right? That's 18 degrees, right? All right.
And then 360 divided by 5 is 72.
Exactly. 360. Put it over here. 360 divided by 5 gives me what? 72. So they are all 72 degrees apart from each other, right? So my second one now is going to be what? Oh, you guys, you got it, man. Because cosine of 0. Okay? Yeah, it's recorded. Yeah, so that gives me what now? 90, right? Okay, my third one is what?
90 plus 18.
90 plus 18, which gives me,
Oh, no, wait.
no, I'm sorry.
62.
90 plus 72, which gives me
62.
162. My fourth one is gonna be 162 plus,
32.
which is
234.
234. And the last, my fifth one is,
306.
okay, oh yeah?
And 234 plus 32.
Yeah, okay, 234, yes? Yeah, no.
Okay.
Equals the other two.
All right, guys. That's what you can find where they started. And let's put it now. 90 is right here. 162. This is 180. Hold up, 162 right here. 234. This is 225. 234 is somewhere down here. And 306 is probably somewhere, I don't know, 330, 350. I don't know. I can't. 270. It's probably somewhere down here. Right? I'm gonna just, all right, like you're gonna do this, I'm just gonna do it. You're gonna do that, you're gonna do that, you're gonna do that, you're gonna do that. All right, see that? Good? All right. So, hey,
Hey, you need to put that.
yeah. Hey, take Goose color. I thought I wrote it down somewhere. Here we go. Home screen, to menu, C, then okay. All right, here we go. Just make it look good, guys, because I'll give you a couple of these. You can go outside. Okay. Yeah, no, yeah. This one here? Yeah, this is a circle right here. You know that, it's a circle. Yeah. So when N is 1, this is a circle. Yeah. Because you have 4 pockets. I'll look there. Hey, Simpson, I want to show you real life examples. So we come here. Microphone. And you're out.